Velammal Nexus kids. Yesterday we saw what about artificial intelligence and their applications. Today we are going to see what is machine learning and a brief introduction on machine learning and their applications. So let's go through the session. So today we are going to see what is machine learning and why is machine learning important and what are the machine learning use cases, and discuss briefly on machine learning methods and how does machine learning works and know the history of machine learning. So let's go through what is machine learning. So machine learning is the idea that there are generic algorithms that can tell you something interesting about a set of data without you having to write any custom code specific to the problem. Instead of writing code, you feed data to the generic algorithm and it builds its own logic based on the data. We know humans learn from their past experience and machines follow instructions given for humans, but if humans can train the machines to learn from the past data and to what humans can do act much faster. Well, that's called machine learning, but it's a lot more than just learning. It's also about understanding and reasoning. For example, one kind of algorithm is a classification algorithm. It can put into different groups. The same classification algorithm used to recognize handwritten numbers could also be used to classify emails into spam and not spam without changing a line of code. It's the same algorithm, but it's fed different training data, so it comes up with different classification logic. So, let's jump into how do machines learn. To keep things simple, just know that machines learn by finding patterns in similar data. Think of data as information you acquire from the world. The more data you give to a machine, the smarter it gets. But not all the data are the same. Imagine you are a pirate and your life mission was to find the buried treasure somewhere in the island. In order to find the treasure, you are going to need sufficient amount of information, right? Like data, this information can either lead you to the right direction or wrong direction. The better the information or data that is obtained, the more uncertainty is reduced, and vice versa. So it's important to keep in mind the data you are giving to your machine to learn is enough. More data beats better models. Better data beats more data. By Newman. After a sufficient amount of data is given, then the machine can make predictions. Machine can predict the future as long as the future doesn't look too different from the past. Machine learns really by using old data to get information about what's the most likelihood that will happen. If the old data looks a lot like a new data, then the things you can say about the old data will probably be relevant to the new data. So it's like looking back to forth. Okay, let's jump into the topic, is machine learning is magic? Once you start seeing how easily machine learning techniques can be applied to problems that seem really hard, like handwriting recognition, you start to get the feeling that you could use machine learning to solve any problem and get an answer as long as you have enough data. Just feed in the data and watch the computer magically figure out the equation that fits the data. But it's important to remember the machine learning only works with the problem. It's actually solvable with the data you have. Okay, let's jump into history of data. So, history of data and history of machine learning. The history of machine learning is quite convoluted. Machine learning is not a monolithic concept but a collection of tools and techniques which have their own separate origins throughout the past 70 years or more. but still there were points in time which could be labeled significant enough to have manifest machine learning in most form we see it today. So before we take a tour down memory lane, let's pay homage to the father of automata, Alan Turing. In year 1950, Alan Turing developed the Turing test during this year. So, the Turing test, also called imitation game, had one objective: to predict if a machine is able to think like a human. While the technique is quite primitive by today's standard, the philosophical implications have had a big impact on the development of AI. A Turing test is defined as a game of question and answer played by humans and a machine, and the person asking those questions is also a machine. Cool, right? This machine's job is to process the response provided by the machine and human player and judge whether the machine is a human or otherwise. Turing predicted that by the 21st century we would have machines capable of passing humans. Unfortunately, that is not the case. I mean, just take chatbots for example. Even we do not explicitly know it's a chatbot we are talking about. So, we are easily able to see through its distinguish and identify it is a program or not a real person. In 1957, introduction of perceptron. Deemed the first ever neural network was designed this year by Frank Rosbatt. Neuron comprises of very popular and comprising subset of machine learning called deep learning. It is one of the most promising machine learning tools we have at our disposal today. In year 1960, MIT developed a natural language processing program to act as a therapist. The program was called ELIZA. It was quite a success experimentally, but it was still using scripting to do its magic. Nonetheless, it was a key milestone for the development of natural language processing called NLP, which is again a subset of machine learning, and it is widely used today. In year 1967, the advent of nearest neighbor algorithm, NN algorithm, was very popularly used in search and approximation. The key nearest neighbor, or KNN, is one of the most popular machine learning algorithms today. In year 1970, the backpropagation comes into play that takes the shape. Backpropagation is a set of algorithms used extensively in deep learning. They dynamically alter the deep learning neural network to effectively do self-corrections. In year 1980, we successfully built a multi-layered neural network called ANN by Kunenko. So, what is ANN? So, ANN is Artificial Neural Network, which acted as a platform for development of convoluted neural networks down the line. In year 1981, Gerald built a new way to tech machines, and he called its explanation-based learning. This was a very early machine learning implementation, and it is processed data to create a set of rules, which is another way of saying that is created an algorithm. Okay. In year 1989, reinforcement learning comes into play, and it is finally realized. Okay. Q-learning algorithm is developed by Christopher, which made it possible to use reinforcement learning in practical applications. For example, teaching a machine to play a risk versus reward game. In year 1995, rise of two very important algorithms in machine learning space, random forest algorithm and support vector machine. In the year 1997, the LSTM was introduced by STEP, and LSTN revolutionized NLP research and application. Along with this, MINIS database was also developed of a team led by Jan LeCun. The MINIS database is regarded as a benchmark in training machine learning algorithms for handwriting recognition. In year 2006, Hilton, regarded as the father of deep learning, coined this very term this year along with Netflix, starting a competition to beat its recommender system's accuracy in predicting user scores by 10%. This competition was won in 2009. Okay, let's see what's the history in 2009. ImageNet is created, which facilitated computer vision research by giving researchers access to vast database categorized by objects and features. It was a project initiated by Fei Li from Stanford University. In year 2010 till now, Google Brain and Facebook Deepfake are now revolutionizing machine learning and pushing boundaries. Google Brain has successfully reached a cat's level of intelligence and now even browse and use YouTube and correctly predict or identify which video contains a cat. On the other hand, Facebook's deepfakes can now identify people with accuracy figuring exceeding 97%. That's great, right? Let's jump into what is algorithm. Okay, before going to types of machine learning, we need to know about what is algorithm and what types of algorithms are being used in machine learning. Okay, so let's define algorithm. So given the attention of machine learning has received and sophisticated problem in its solving, it may seem like magic, but it is not. It's built on a foundation of mathematics, statistics developed over many decades. One very practical way to think of machine learning is a unique way of programming computers. Most programming that is not machine learning and the practical programs that humans have dealt with the most over last 50 years is procedural. It's essential a set of rules defined by human. This rule set is called algorithm. In machine learning, the underlying algorithm is selected or designed by a human. However, the algorithm learns from the data rather than human intervention about the parameters that will shape a mathematical model for making predictions. Humans don't know or set those parameters. The machine does. Put another way, a data set is used to train a mathematical model so that when it sees the similar data in future, it knows what to do with it. Models typically take as an input and then output a prediction of something of their interest. Let's jump into types of machine learning. So, the important definition of types of machine learning or methods of machine learning is. So, in supervised learning, the answer or result portion of an example is called label. In each example, in a label data set consists of one or more feature and a label. For instance, in a house price data set, the feature might include the number of bedrooms, the number of bathrooms, and the age of house, while the label might be house price in this. In a spam detection dataset, the feature might include the subject line, the sender, and the email message itself, while the label would probably either spam or ham, that is called not spam. So there are three main categories of machine learning methods. So we will go one by one. First is supervised learning. The machine learns from labeled data. Normally the data is labeled by humans. Unsupervised learning. The machine learns from unlabeled data, meaning there is no right answers given by the machine to learn. But the machine must hopefully find the patterns from the data to come up with an answer. That is called unsupervised learning. So what is reinforcement learning? So the reinforcement learning learns through the reward-based system. So let's go through the types of machine learning briefly with applications. Can you match the right machine learning categorization? So now we have three types of machine learning. So we have supervised learning, unsupervised learning, and reinforcement learning. So now the clouds are shuffled. So can you reshuffle and match it? I'll give 5 to 10 seconds of time. You can do it. Okay. Now let's go through the answer. First is supervised learning. So what is supervised learning? It learns from predefined data, that is historical data. So you need to explicitly train the machine to do a specific task or predict a specific, so that is train me. So second one is unsupervised learning. So what is unsupervised learning? You don't want to explicitly train them, but it finds a pattern from the data itself. So that is, I am self-sufficient in learning. So the third one is reinforcement learning. So it learns from trial and error method. Yeah, my life, my rules. So it learns from trial and error. So first, let's go through supervised learning. Supervised learning is the first type of machine learning in which labeled data are used to train the algorithms. In supervised learning, algorithms are trained using marked data where input and output are known. We input the data in the learning algorithm as a set of inputs, which is called features, denoted by X, along with the corresponding outputs, which is indicated by Y, and the algorithm learns by comparing its actual production with the correct output to find errors. It then modifies the model accordingly. The raw data is divided into two parts. The first part is for training the algorithm, and the other region is used to test the trained algorithms. Supervised learning uses the data patterns to predict the value of additional data for. This method is commonly used in applications where historical data predict likely upcoming events. For example, it can anticipate when transactions are likely to be fraudulent or which insurance customer is expected to file a claim. So, let's see what are the types of supervised learning. So, the supervised learning made into two parts are classification and regression. So, let's see what is regression. So, regression is a type of supervised learning in which labeled data are used, and this data is used to make predictions in a continuous form. The output of the input is always ongoing and the graph is linear. Regression is a form of predictive modeling technique which investigates the relationship between the dependent variable and independent variables. So, the dependent variables are called outputs and the independent variables are called inputs. This technique used for forecasting the weather, time series, modeling, process optimization. One of the examples of regression technique is house price prediction, where the price of the house will predict from the inputs such as number of rooms, locality, ease of transport, age of house, area of a home. Okay, let's jump into classification. So what is classification? From that name, classification is to classify the data set. Is it a cat or dog? Yeah. So classification is a type of supervised learning in which labeled data can use, and this data is used to make predictions in a non-continuous form. So the output of the information is not always continuous and the graph is non-linear. So what is continuous and non-continuous? So continuous is something like 0.58, but if it is non-continuous, it's a discrete form. So the regression is a continuous and the classification is non-continuous, that is discrete. So it might be 0, 1, 2 or a discrete value. And the graph is non-linear in classification problem. So in classification technique, the algorithm learns from the data input given to it and then uses this learning to classify new observations. This data set may merely be by class. By class, it's 0 or 1. Or it may be multi-class too, 0, 1, 2, so on up to a finite number. For example, one of the examples of classification problem is to check whether the email is spam or ham, that is not spam, by training the algorithm for different spam messages. So what is unsupervised learning? Unsupervised learning is the second type of machine learning in which unlabeled data are used to train the algorithm, which means it is used against the data that has no historical labels. What is being shown must figure out by the algorithm. The purpose is to explore the data and find some structure within. The unsupervised learning, the data is unlabeled and the input of the raw information directly to the algorithm without pre-processing of the data and without knowing the output of the data that is being used. And the data cannot be divided into a training and test data. The algorithm figures out the data and according to the data segments, it makes cluster of the data with new labels. This learning technique works well on transactional data. For example, it can identify segments of customers with similar attributes who can then be treated similarly in marketing campaigns. Or it can be used to find the primary qualities that separate customer segments from each other. These algorithms are also used to segment text topics, recommend items, and identify data outliers. So, let's go to the topic of clustering. So, clustering is a type of unsupervised learning in which unlabeled data are used, and it is the process of grouping similar entities together. And then group the data is used to make clusters. The goal of the unsupervised learning is to find similarities in the data points and group together. Group together according to the similar data points and figures out a new data should be belong to which cluster they belongs to. So, association problem. Unsupervised learning tries to solve this problem by trying to understand the rules and meaning behind the different groups. Finding a relationship between customer purchases is a common example of an association problem. Stores may want to know what type of products we purchase together and could possibly use this information to organize the placement of these products for easy access. One store found out that there was a strong association between the customers buying beer and diapers. They deducted from this statement that males who had went out to buy diapers for their babies also tend to buy beers as well. Reinforcement learning. Reinforcement learning is the third type of machine learning in which no raw data is given as an input. Instead, reinforcement learning algorithms have to figure out the situation on their own. The information learning frequently used for robotics, gaming, and navigations. With reinforcement learning, the algorithm discovers through trial and error which actions yield the most significant rewards. This type of training has three main components, which are agent, which can be described the learner or decision maker, the environment, which describes as everything the agent interacts with, and action, which represents as what the action can do. So that's it for machine learning. So we have covered what is machine learning and the history of machine learning and why we use machine learning and its importance, how does machine learning works, and we have discussed briefly on machine learning methods and their use cases. So now let's summarize the types of machine learning. So first is supervised learning. In supervised learning, we have labeled data and we have direct feedback, that is direct prediction, and we predict the outcome and future. So that is used in predicting the future. For example, stock price prediction. Second is unsupervised learning. So there is no labels and there is no input and there is no feedbacks, and it finds the hidden structure in the data. So it finds the patterns in the data and groups it. So that is unsupervised learning. So let's go through reinforcement learning. So we have decision process, we have reward system, and learn series of actions. Walkthrough on Google Teachable Mission. So what is Google Teachable Mission? It is a platform for you to train your system to identify and recognize sounds, poses, and even images. So Teachable Machine Learning is a cool, new and easy tool to create machine learning models of your own, sites, apps and more with zero codes. Let us take a tour of it. Go to https://teachablemission.withgoogle.com/. So it would be something like this. The engine works by getting the data set from the user, then trains on the data provided and lastly predicts the outcome. As mentioned earlier, this model can be downloaded too. Scroll the site to a better understanding of the engine. Click on Get Started. There would be 3 options in front of you. As of now, we will be going up with the image project. It would look something like this. So we'll be adding the data set to the respective classes. Name the class. It's me. Okay. So this is a classification problem. Okay. Because we have class 1 and class 2. So here in the screen in Teachable Machine, you can see my image and class 2. So class 1 is me and class 2 is another class. So which is fed to training model and then you can preview. So first what I'm going to do is hold on to the camera and record it. Take the samples of image of myself in different poses. And then after taking the sample of images, go to the class 2, then click on it and you can have your bottle with me and record it. So take the samples here, me and my water bottle. Yeah. So name it me plus bottle and train the model. So I have taken myself as an image sample and another classification is me and my bottle. So the training data is being fed to the training model. It is a classification model. So wait for a few seconds until the model trained itself. So after training, you can export your model if it is all good. You can export the model in JS or p5.js. Okay, now let's test the model. So now it's me, and then now it's me with my bottle. Can you see? The second class shows 100%. Now the first class is me. Can you differentiate? So the machine is classifying me and me with my water bottle. So this is the example of classification model. You can also try in your home. Hope you understood this and enjoy machine learning. Thank you.